we're going to have on stage Ian Gebbie. Ian Gebbie is going to talk more about the multidiscipline engineering design packages. We will see what Ian and DRA are using, if they are using in COMOS indeed or something else. Ian, welcome, and over to you.
Good afternoon, everyone. It's a pleasure to be able to talk to you and share with you. Let me just see if some slides come. There we go. As Teko said, I'm going to discuss how we're using our design tools and also sort of just touch on how ready we are in the digital twinning space. I'll touch a bit on digital twinning as it does mean many different things for different folk. I'll then take you through fairly quickly on some of what we've developed within COMOS, touch on some of the gaps as we see them currently, and then some of the issues that we've seen in using the tool in a project environment. Just before I get started, DRA is an engineering house doing EPCM and EPC projects, everything from mine planning, open cast or underground services, through to water in my department, or the EC&I engineering, operations infrastructure, quite a bit of energy work happening at the moment, and ports and harbors. Digital twinning, what do we mean? If you look at IBM's definition of a digital twin is a virtual representation of an object or system that spans its life cycle. Very important aspect of the definition is updated from real-time data and uses simulation, machine learning, and reasoning to help decision making. I don't think we're quite there. We are, however, using it as a design tool to model what we intend to build, and you just heard from Mark, from the owner's point of view, then gives you a platform to maintain the system through its life cycle. From our point of view, there are many things that could go into the digital twin: instrument designs, electrical designs, simulations, process models, 3D models, structural models, etc. Later on, I will show you what we are using and what we are not using in all of that. So COMOS, I think this is a different representation of what Mark has just shown in terms of the timeline, in terms of the tools that are available. What I've highlighted here is the aspects of COMOS as we as an engineering house are using. So we're using the P&ID tools, we're using the piping tools, we're very certainly using all the electrical control and instrumentation tools. There are aspects of it in the broader life cycle that we'll enable, but we're not necessarily the end users. So where are we? What do we have currently? DRA, we're using the P&ID tools, so we're doing all our piping instrumentation diagrams in COMOS, and we're integrating that process data right through to instrumentation and electrics, which is why we'd want to use these tools and where their strengths are. Electrically, we're using the package as well. We're pushing out cable schedules, schematics, cable block diagrams, etc. We find all these tools, using them from instrumentation drives them, and we're certainly using them already on generating data sheets, loop drawings, wiring drawings, hookups, etc. And we started pushing it into the control space, using it for IO counts, IO assignments, network drawings. I'm going to leave this on the slides for your reference, but for interest of time, I'm going to talk through, over them. But this is an example of one of the many P&IDs we've done using within the tools. It just happened to be a large conveyor coming out from underground. So all these symbols that you're seeing here would have process data and instrumentation data behind them, which is why these tools are so important. That data is then available to us from a design point of view, but also available and a maintenance point of view through the life cycle of the operation. Again, electrically, the tool is getting used in our design platforms. This is an example of a LV single line diagram showing a MCC and its distribution that allows me to see what starters are assigned where, and cables are assigned to particular loads. This is a schematic I've just taken from one of our projects that we're busy with at the moment. So again, the power on these tools is that the information is live. If the size of this motor had to change, the schematic would get updated automatically. If I change the cable data, the schematic would be updated. This is an example of a loop drawing. Looks like a 4-wire instrument. I'm going to have to go and study that a little bit, actually. Or I've got an auxiliary alarm on the top there. So a lot of complexity is available for us within the tool to produce instrument drawings and loop drawings in the way that we want them. We are fairly particular about the detail that we want on a loop drawing, and the information. You'll see we always try and get power supply information through IO cards and then shown out. In the past, many of the tools would only give you from IO out, and you couldn't actually follow the whole circuit through. On COMOS, we're getting the outputs that we want in the way that you can see the full circuit and then help you with fault finding. This is a very powerful aspect of COMOS. I'm afraid the text will be a bit small for you to see in your format, but cable block diagrams, I can give this to a contractor and say, right, these are all the cables that you're pulling, give him more of a holistic view. He'd obviously work with us together with the cable schedule as he's pulling, but use this to plan his construction job for the day. We're starting to use COMOS and bring in aspects of our 3D models. We always have extensive 3D modeling on any project that we build. Instead of doing a 2D drawing within COMOS, we're now linking in all our instrument tags, process tags, to highlight where things are, and then we'll hand this over as a location drawing to a contractor so you can see where the pumps are, where various instrumentation is on that particular site. The 3D integration that we have so far within COMOS is limited, and it's probably more of us as a user need to investing more time to get our existing 3D tools to integrate into COMOS. This is quite unique for the design tools that are around. We're seeing COMOS being structured to allow close integration from instrumentation design into control systems design, which we like, especially as a lot of our designs, let's say if you're using EZBus, for example, the integration between control and instrumentation is very tight. We can pull out the network drawings that we want done in COMOS, link that through to our PLCs. We haven't closed that loop yet, but we certainly know that it's possible. But this network design was done in COMOS, and we would construct off documentation like this. So how do we use the design platform? At the moment, we use it for our electrical control instrumentation design. We use it for our process design and PNIDs. We can see the benefit of using it in our logic designs as part of the control systems work. What we don't do is we don't do it in our 3D integration. So there is a gap. How do you go from PNID piping instrumentation drawing, the instrumentation side is strong, into a piping space that you can do piping engineering? And in the workflows that we have and in the modeling tools that we have, we're working quite hard at the moment on what that integration is going to look like. At the moment, it'll be an export of piping lists and numbers and specs into a separate package that we've been using for our 3D piping design and our 3D model space design. And then we don't use COMOS on the simulation point of view. So the mass balance from a process point of view is done elsewhere. The load flows electrically, we still do elsewhere. And there is use something like ETAP. Often that is done still on Excel. And then the results of that would inform a single line diagram that would come into the tool. All right, so why would people want to use COMOS? And I think you've heard the benefits from Mark that's just spoken before me, that you have a tool now that will give you a representation of the design and how it's been commissioned, and can be used through the life cycle of the operation 20, 30 years down the line. So many times the client's going to make small changes to instrumentation, electric design, small little projects. It's not worthwhile bringing in an EPC to go and manage that. You want folk on the site to say, right, I want to go and add another instrument, or I want to change the size of this motor, but you want to keep that data up to date. It means that this whole database, this twin, if you like, moves over to the client, and he does it as an engineering tool and then keeps it up to date. So we're seeing small projects with design updates. We're seeing the operational folk having access to the design information, all the IO allocations that we made, all the sizing information that we used. You can update those changes. You can produce maintenance schedules down the line, and you've got access to all the data sheets that you can use for maintenance and purchasing the spares, etc. We have seen some traps. On the positive sides, I've got multiple people working on a project at any point in time. I've got sharing of data going, which is better than we've had in many other tools, between process, instrumentation, electrical, and back and forth. We see the tools being able to define maintenance needs down the line, although our primary focus as an EPC is to construct. We certainly see the advantages coming down the line. COMOS has been difficult from a setup point of view. The data structure of any design tool like this needs to take into account the engineering workflow. Too often we see design tools that says, if you want to add an instrument, go and select the model of and make of the instrument that you are going to use and drop it into the design. The real world doesn't work like that. When I start a project, I know that there is an instrument there maybe. Then as it colors in and the design develops, I get to go, okay, yes, there's a level transmitter, and yes, I think it might be an ultrasonic, but which vendor, which make, which model, I don't know yet. But I do want to start putting out data sheets. I do want to have a tag assigned. I want to be able to get process data. I want to be able to get mechanical data, tank heights, etc. And then I want to be able to color that information into much more detail through the engineering process. And there are not many tools that can do that. We've made a lot of modifications to the COMOS structure to enable this, to enable the tool to be used in the engineering flow. Then we also, and it's one of the issues we're struggling with at the moment, there needs to be a controlled flow of information between disciplines. I can't have ordered a flow meter from a manufacturer, have it sitting at the workshop, and then find the process engineers decided he doesn't need it and deleted it, and I don't get to know about it as an instrument engineer. That whole workflow and consequence of change needs to be managed within the tool. Again, that is a setup issue on COMOS that currently we're struggling with. We see the tool can be doing, but we're going to have to rework some of the setup to enable that between its working layers, so that if a change is made by a third party, we can manage that change in each discipline. There are other design tools that do this a lot better. I'll touch on that just now. And then, how do we control access to who changes what? How do we control it without destroying the initiative of the engineers that are working. We as DRA do use other tools. You heard Mark talk about InTools or the smart plant instrumentation. We currently engineer extensively using the DESsoft, which is the old derivative from the PySystems. PySys system rather. We do probably half of our projects at the moment on the DESsoft platform. Very strong on instrumentation. We've struggled with it on the electrical side. And we've never got the traction on the PNID. So COMOS has really got our process team and our instrumentation team working closely together in a project that we've never been able to achieve to this extent before. There are other tools that we're investigating. The Viva suite is of interest. The ePlan suite has evolved extensively from a process point of view, and some of the data structures are a lot easier. So, depending on the client and the platform, there are some other tools that, from an engineering point of view, give us some advantages. All right. Thank you very much. I hope you found that interesting, and I'd be more than happy to field questions down the line if anyone wants to know more.
Thank you very much, Ian. Yes, the interesting fact is also the gaps that DRA has identified. And I hope, as like the rest of us, that sessions like this would then, end of the day, come up with a plan on how to address some of the challenges that yourselves as DRA, and I suppose all the other EPCs are facing. So thank you very much, Ian. There is a couple of questions, but we'll save those for the Q&A session at the end.
Perfect.